Okay, now mesh analysis. So as per previous class, we finished node analysis. Okay, node analysis with the current source. Now mesh analysis is basically with a voltage source. So mesh analysis provides general procedure for analyzing circuits using mesh currents as the circuit variables. So in previous topic, node voltages for node analysis. Here mesh analysis, mesh currents we need. So we need a loop current generally. Mesh means loop currents. A mesh is a loop that does not contain any other loops within it. Means a mesh is a loop which does not contain, means it doesn't have any other loops. Only one loop means only one loop, no other branches, nothing. So only one loop it should cover. How it is covered, we will check. Using mesh currents instead of element currents as circuit variable is convenient and reduces the number of equations that must be solved simultaneously. Using mesh currents instead of element currents as circuit variables, convenient and reduces the number of equations that must solve simultaneously. Means continuous one mesh current is easy to solve the solution. Okay, mesh analysis applies KVL to find unknown currents. What is KVL? Kirchhoff's voltage law. Kirchhoff's voltage law we can use for finding the mesh analysis. Mesh analysis applies KVL, Kirchhoff's voltage law. Now see here one example circuit here. Figure having how many branches? 1, 2, 3, 4, 5 branches. Right? Voltage source, 2 voltage source and 3 resistances. Total 5 branches. Here no need of any reference node here. Reference 0 voltage or ground, no need here. This general circuit, if any general circuit is given, we can start doing. No need of thinking about where is the ground, no need. Just what we have to do, see the closed paths. How many closed paths are there? You can see here 1, resistance 1, resistance 3 and voltage source V1 will make a one closed path. Then resistance R3, R2 and V2 voltage source will make another closed path. So we have 2 loops in this. Another rule. You can, before starting how many loops are there, you can note down what are the nodes first. A, B, C, D, E, F. These are the path nodes. Okay. Now we can start from the first node A, go to the B, then go to the E, F, then come back to the A. This is the loop rule. What is the loop rule? Start with the one particular node, go with the other nodes and come back to the same node and it become one loop. Same second loop, B, C, D and E will become another loop. Now 2 loops are there. But one confusion will there. Datur, we can ask A, B, C, D, E, F also one loop? No. Because current cannot jump from this resistance R3. When loop is going, must be a one inner closure loop. Outer closure loop we are not considering. Because in this closure loop ABC, there is a junction R3 where current will divide there. So we cannot consider that one. That we have to take care. So the paths are A, B, E, F, A and B, C, E, B. Paths are B, C, D, E. Right. B, C, D, E, B again. So these 2 are the paths already mentioned here. What are the A, B, E, F, A, B, C, D, E, B? 2 are the mesh paths here. These mesh paths. Now coming to the another one what I mentioned. But the path A, B, C, D, E, F, A is not a mesh. Mesh means a closed loop. The current through the a mesh is known as a mesh current. Loop current, mesh current, same. Okay, mesh current. We now new name mesh current will call. In mesh analysis, we are interested in applying Kirchhoff's voltage law. In node analysis, we are interested in applying Kirchhoff's current law. But in mesh analysis, always apply Kirchhoff's voltage law to find the currents in the given circuit. Now, in the mesh analysis of a various circuit with n meshes, we take the following 3 steps. So, like the 3 steps in the node analysis, here also we have 3 steps. What is the first step? Assign mesh currents I1, I2 or IN to the meshes see loop currents, mesh currents is like this. The saham is here, rotation saham. The arrow will come. That is your mesh currents. 1, 2, 3 up to n meshes, n currents. Now apply KVL to each of them n meshes using Ohm's law to express the voltages in terms of the mesh currents. Now we write I1, right? You have to use the Ohm's law. Ohm's law here, voltage V1 as it is. Now here Ohm's law, what is here? I1 R1. This is the Ohm's law. Now convert it into voltage also, no problem. Next here also R3, I1 R3 is another voltage. So like this we have all the voltages here. Ohm's law, we have to use Ohm's law to write the voltages. Now solve the resulting n simultaneous equation to get the mesh current. So once you get the n number of mesh equations, you can solve n number of mesh equations to get the n number of currents first. First voltages, then currents. We can check it. Voltages means we are getting voltages in the mesh equation with the current form. Ohm's law, V is equal to IR. So that I and R is in the format current and resistance. So the mesh equation will be in the form of current and resistance. Node analysis, the equation in the form of voltage divided by resistance was there. Here the mesh equation says current multiplied by R. Let's see one example. This example is having same, no, we are continuing how to solve. So once you get the mesh equations, you have to solve the mesh equation to get the currents. So the first step requires that mesh currents I1, I2 are assigned to mesh 1 and 2. So this is I1, which is capital I1 is current in the resistance. Capital I2 is a current in the resistance R2. Capital I3 current in the resistance R3. This is different current. Mesh current is small I1, small I2. Mesh current is different. Branch current is different. So that's why the huruf, the letter is capital and small. So be careful when you are writing. Don't confuse with the letters. Small letters for the mesh current and capital letter for the branch current. Okay. It is quite opposite to the node analysis. Node analysis, small huruf, that is small letter, is for branch current, and capital letter is the source current. Source current, capital letter I1, I2, capital I1, capital I2, capital I3 is for source current, and small I1, small I2, small I3 for branch current, element current. But in mesh, completely opposite. Small I1, I2 are the mesh currents. Capital I1, I2, I3 are the branch current. So now it is conventional to assume that each mesh current flows clockwise. You can assume anti-clockwise also. It's up to you. Like in the node analysis, the current direction in each branch you can assume, right? I told you when the result comes, if it is coming minus, it tells that what you assumed is reverse. So here also the mesh current direction, the loop current direction, you can assume clockwise in general. Anti-clockwise also no problem, but follow one method. So clockwise always follow it. The second step, we apply KVL to each mesh. KVL to each mesh. So first mesh, what is the KVL? Kirchhoff's voltage law. So start from this point, from this voltage, that is V1 voltage, KVL voltage law. So current leaving from the source. So V1. So current entering the resistance. It is I1 R1, right? Now here small change is there. See here, current is leaving always minus, same, right? Current leaving is minus V1, plus current is entering resistance R1 small I1. This I am considering I1 R1. Then R3. In this R3, what are the current? I1, but it is not sufficient because I2 is also moving in the R3. Both currents in R3 is depending. Okay, R3 is depending on both the currents, first loop and second loop. How the current in R3 is downward. How the current in the R3 based upon the second loop? Upward. Okay, so downward is nothing but positive and this upward is negative, opposite. So I1 minus I2. So R3 times I1 minus I2, which is equal to 0. First loop equation. Now, as like a node analysis, always arrange equation in terms of first term, second term variable equal to constants. Here also, what are the variables? In this, what are the variables? I1, I2, right? I1, I2, small I1, I2 are the variables. What are the constants? R voltage source. V is a constant. You take it other side. Solve the equation such that I1 plus I2 or I1 minus I2 equal to something like that. So we'll see in the example problem. So we can write like this. See, I1, R1 plus R3 times I1 we can write minus R3 I2 equal to V1. V1 having the some value in the question it will given. So R1, R3 is given in the question. V1 is given in the question. So unknown are I1 and I2 only. Okay, so we have to form the equation in such a form that I1, I2 will be on the left hand side, that is variables, on the right hand side constant. Now second loop. Coming to the second loop, I will start with R3, no problem. So R3, when I taking the direction, what it will be? I2 as a reference. So leaving the I3 entering. So I2 minus I1 or I1 minus I2? I1 minus I2 time. Yes. I2 minus I1. Why? See, which is the reference or the direction of the current? Our reference is the direction of the current. I2 is, we assumed, in which direction. So this, how is entering or leaving, we have to decide. In this V2, current is entering to the plus. When current is entering the plus, it is a V2 plus V. See, plus V. Here, minus V1. How? This I1 is leaving the plus. So minus. Here, current is entering the plus. So it is plus V2. So like this, move with this current only. Move with this current. Go to the R3. This direction is our reference. Then R3 is there nothing but what? I2 is our reference. So I2 minus I1. Our reference is I2. So I2 is entering the resistance. So I2 minus I1 times R3. I2 minus I1 times R3. Check with our direction. Our direction. What is our direction? I2 is our direction. So starting point of the resistance is down only. So when starting point is, this is a higher potential. This is lower potential. So as per that, I2 is the having maximum value. So in opposition, I1. So I2 minus I1 R3. Same R2 plus R2 I2, because our direction only is there. So this is your equation. Here you will get some confusion in the second loop. First loop, okay, as it is, normal KVL you can apply. But in second loop, our reference direction we have to take. Our reference direction is I2, not the direction of this capital I2, small I2. No. What is the direction of our loop direction, mesh direction, what it is. So same rule. Direction of I2 is entering the plus of the source. So it is plus V2. If it is leaving, it is minus. Plus V2, it is entering. So plus V2. Now R3, I2 is the main reference. So I2 minus I1, the other one. Then here also in R2, I2 is entering the R2. So plus R2 I2. So like this, you have to write the equation and rearrange. When you rearrange the equation in terms of variables and constant, R3 I1 minus R3 I1 plus R2 R3 times I2 equal to minus V2. So this equation and this equation form the two major simultaneous equations. We have now two techniques. One is elimination technique and Cramer's rule technique. Cramer's rules I prefer. Okay. The third step is to solve the mesh currents, putting the equation 3.13 and 3.12 in matrix form. Cramer's rule method. So what is the first one? R1 plus R3 minus R3. R1 plus R3 minus R3. Minus R3, R2 plus R3. Minus R3, R2 plus R3. And I1 and I2. So I1 and I2 as it is. Other side V1 is there, minus V2 is there. Other side V1 is there, minus V2 is there. So now take down the determinant. Then take down the determinant 1 by V1 and V2, replacing these two elements, determinant 1. And replace the R3 and R2 plus R3 with V1 and minus V2, take out another determinant delta 2, which will give the two determinant values, and basic determinant value we already found. So delta 1 by delta is V1, right? Yeah, delta I1, sorry. I1 is delta 1 by delta. Next, I2 is delta 2 by delta. So which we can solve after the mesh currents. Notice that the branch currents are different from the mesh currents unless the mesh is isolated. So we are not isolating any mesh. So branch currents and mesh currents are different. That's why small letter and capital letter major role plays. Okay, we use I, small I for mesh currents and capital I for the branch currents. Where I1 and I1 with capital I1, which branch current, capital I1 is also equal to small I1 in the same direction. Next I2, where is I2? Here. Capital I2 is equal to small I2. Okay, coming to I3, it is different. I3, now I3 its direction. I3 is its direction. So I3 direction is I1. Same direction is I1. So I1 minus I2. Because I3 what we assume, that is the reference direction. From that point of view, in the same direction I1 is there. Opposite direction I2 is there. So I1 minus I2. If you assume this I3 in reverse direction, then it will become I2 minus I1. So like this we have to form the equation. Let's have an example. Find the for the circuit, find the branch currents I1, I2, I3 using mesh analysis. Check the circuit. See here voltage source is one is here, another voltage source is here. Here only resistance, not like the previous one. Okay, we have how many resistances? 1, 2, 3, 4. And how many voltage sources? 2. So how many branches? 6 branches are there. You can make here another node also, no problem, because these are in series, no problem. Okay, total 6 branches. But how many currents we need? 1, 2 and 3 currents we need only. Branch currents are 3 only. Okay. Now next we have to form a loop. First loop and second loop. First loop, what is the equation we can write? Because current is leaving from the plus, this I1 is leaving from the plus, it is minus 15. Current is entering in the 5, it is plus 5 times I1. 5 times I1. Now current is entering 10. 10 times I1 minus I2. Because these are 2 currents are there in this 10. 2 currents. I1 is downwards and I2 is upwards. So I1 minus I2. Next, and current is entering, not leaving, entering. So plus 10. So be careful. Here it is minus 15. Here it is plus 10. So sure. So next, first equation. Now coming to the second loop. It is start from here, no problem. 6. You can start from 6, no problem. So current is entering. So 6 times I2 plus 6 times I4. Okay. 6 times. This is 6 times this I2 plus 6 times I4. Now current is leaving. Leaving means minus. Minus 10. Now. No. Our direction. Plus 10. Plus 10. Plus 10. I2 is the reference. So I2 minus I1. I2 minus I1 plus 10 because current entering the resistance. I2 is the reference point. Okay. Now check. Now minus 15. Our what we checked. Okay. Now plus 5 I1. Then 10 times I1 minus I2 plus 10 because entering. So if you rearrange, you will get this equation 3 I1 minus 2 I2 minus equal to 1. Now coming to the second loop, somewhat tricky. You can check here. 6 I2 plus 4 I2, good. 10 I2 minus I1, okay. 10 I2 minus I1 minus 10 because leaving. Yes. Minus 10 because leaving. Now rearrange this equation. I1 is equal to 2 I2 minus I1. You can put I2 here also. I1 minus 2 I2 equal to minus I1. You have to rearrange this one. Okay, now by using elimination technique, I1 is equal to 2 I2 minus I1, substitute here in this. Then you will get I2. That is 1 ampere. Then you will get I1. That is I1 also 1 ampere. I2 is also 1 ampere. I1 also 1 ampere. Now what is I1? Capital I1. Branch current I1 is nothing but small I1. That is same 1 ampere. What is I2? Loop current I2 is nothing but capital I2. That is also 1 ampere. Now what is I3? I3 how much? This I3. Capital I3 how much? This is the reference point. No. Current based upon the loop currents. What is I3? I1 minus I2. What is I1? Small I1? 1 ampere. Small I1. And small I2? 1 ampere. 1 minus 1, 0. So I3 is 0. Means in this branch there is no current. Okay? Okay. We can see with the Cramer's rule also. Matrix form. Now substitute 3 minus 2. here, 3 minus 2 here, next 1 minus 2 here. Okay, minus 1 is taking this side and I1 is taking this side. So minus 1 and plus 2. Okay, anything is okay because he is moving this minus 1 to this side and I1 to this side. So minus I1 plus 2I2. This equation, how it will be? Minus, take.
Because I1 is there and 2.
No. My sign is different. Sign check it. Here minus 1 is this one. How much here? Plus 1.
Oh, for the result.
Yeah. That's why he rearranged. He rearranged this one with minus 1. He is taking that side and I1 taking this side. So when I1 is taking this side, what happens? Minus I1 plus 2I2. So minus 1 and 2. Then other side 1. So this is the matrix form. Now just take the determinant. Delta, that is 3 into 2, 6 minus 2 into 1, 2 plus 2. So this is minus 6 minus 2, 4. So overall determinant is 4. Now determinant 1, you have to rearrange this 1 1 instead of 3 minus 1. 3 minus 1 you have to replace with 1 1 and find the determinant. So 2 into 1 minus 2 into 1 minus or minus plus 2 plus 2 4. Now determinant 2. 3 into put 3 minus 1 as it is, rearrange minus 2 and 2 with 1 and 1, this 1 and 1. So this is the determinant matrix. Now find the determinant. 3 into 1 3 minus 1 into 1, then minus or minus plus. So 3 plus 1 4. So all are 4 only. So current will be 1 only. So I1 determinant 1 by 1, that is 4 by 4, 1 ampere. Current I2 determinant 2 by determinant. So 4 by 4, 1 ampere. So same result is coming with elimination technique and with the matrix Cramer's rule method. So now you can substitute what is I1, I2, I3, same like this. So these are the I1 is capital I1 is 1, branch in 1. Capital I2 is 1 ampere in branch 2. Capital I3 is I1 minus I2 in branch 3, that is 0. So this is the first example. Now another last example for this chapter 3. Then you have to practice at your home. Some 4 questions I gave, I think. Okay, the question is find the current I0. Where is I0? Can anyone?
In the middle.
Yeah, here. At the 10 ohms resistance, what is the I0 is there. So he only mentioned what is the I0. No need to name it again. No need to name the current there again. Okay. Now we can name other branches. So the voltage source, the current is I1. This resistance 24 ohms, current I2 I am assuming, and this one current I3. Okay, something is 3 loops are there, but one problem is here. What is that? This
2 resistors.
No, this is this is correct only. This is a loop current, so small I1. This is a loop current, small I2, and this is a loop current, small I3. No problem. You can go ahead. So now coming to the loop equations. What are the first loop equation?
Minus 24.
Because leaving from the plus minus 24, entering here plus 10 I1. Later we'll substitute what is I0 later. Now first our loop equation we have to write. So minus 24 plus 10
I1 minus I2.
10 I1 minus I2. 2 currents are there. Here one loop, here one loop. 2 currents are there in this. Correct?
I1
minus I2 because I2 is in opposite direction, right? Sometimes if you take other direction, it is I1 plus I2. It depends. But now it is in opposite direction. So now coming to the plus 12 times I1 minus I3, right? This is the important here. Now first loop. Now rearrange it. Next, you have to go to the second loop. Second loop is I2. Okay. Second loop. We can start from this 24, no problem. So 24 I2. Now here 4
I2 minus I3.
I2 is a reference. So I2 minus I3. Okay. 4 times I2 minus I3. I2 is a reference. Now coming to the plus 10 times
I1 minus I2.
I2 minus I1. Our reference where I am standing, that is the reference point. Okay. I am talking about I2. That is our main motto. Okay. I2 is first, then Baki. So I2 minus I1. So next third loop. Start with resistance, no problem. 12 times, which is the reference I3. So I3 minus I1 plus 4 times I3 minus I2. Now it is reverse, check. I3 minus I2. Now here, what is this? Entering the plus. So plus, entering, plus 4I0. We need 4I0, right? So what is I0? Later we can substitute. Okay, Ohm's law, as per the Ohm's law, or directly, what is I0? I0 is nothing but I2 minus I1. I0 is downwards, right? So downwards, which is the same, I1 minus I2. I0 is, what is I0? Here.
I1 minus I2.
This I1 minus I2, I0, as per the loop current, right? Getting or not? You didn't get, right? Okay.
Could be
This I0 equation we want, because I0 is a more unknown value, right?
okay.
So we have to rearrange with the loop equations only, loop values only. So this is I0, downward. Downward, which is downward? I1. I1 is the downward, right?
Okay.
So that is reference, I1.
Okay,
And I2 is upward. So I1 minus I2.
And also could be I3 because it's
No. Only in this branch. Only in this branch we have to think.
branch, okay.
Yeah, we are rearranging I0. Where is I0? Here, only in this branch. Don't think about the I3 here. I3 is not dependent there. This I0. No. If whole length, okay, you are correct. But when the 4 ohm resistance not there, if 4 ohm resistance is not there, then it is a whole. Okay. So now check here once again what we discussed. Same it will come, minus 24 plus 10 I1 minus I2 plus 12 I1 minus I3. We can rearrange in I1, I2, I3 format. Next, second loop, 24 I2 plus or minus. Yeah. Plus 24 I2. Where is it? Yeah, plus only. Yeah, that one, 24. So don't confuse with 24 volts source and 24 resistance. Okay, plus 24 I2 plus 4 I2 minus I3, correct? Next, plus 10 I2 minus I1. Now rearrange this, it will become minus 5I1 plus 19 I2 minus 2 I3 equal to 0. Now for mesh 3, what is it? Mesh 3, 4 I0 we are starting. I am starting with 4 I0. So it is entering the current. So plus 4 I0 plus 12 I3 minus I1 plus 4 I3 minus I2 equal to 0. Now rearrange, now substitute what is I0. Okay, but I0 is nothing but I1 minus I2. See here, I0 is nothing but I1 minus I2. So substitute in I0 form, 4 I1 minus I2 you can substitute. Now open this equation, rearrange, minus I1 minus I2 plus 2 I3 equal to 0. So those three are the equations. Now make it in the matrix format. Let's take. What is this? 11 minus 5 minus 6. 11 minus 5 minus 6. Okay. Then minus 5, 19 minus 2. Minus 5, 19 minus 2. Minus 1 minus 1, 2. Minus 1 minus 1, 2. Yeah, I1.
Minus 1 and minus 2.
No, this is I2.
I2, okay.
Minus 1, then 2 I3. So minus 1, 2. Don't confuse with the jumbo. Okay, next I1, I2, I3. On the right side, 12, 0 and 0. Easy now. More zeros is there, easy for our calculation. So that's you are happy. Now, how to find the determinant? I told you, take the 11 and this is your matrix. 19 minus 2 minus 1, 2 is the matrix. So 11 times, this is the matrix. Next, minus 5, then matrix is minus 5 minus 1 minus 2, 2. Minus 5 of minus. Minus 5 minus 1 minus 2 and 2. This is the matrix. Now take the minus 6, then this is the matrix. Minus 5, 19, minus 1, minus 1. Minus 5, 19, minus 1, minus 1, minus 6, that is. But here the summation. First one is plus, next is minus, then plus. So rearrange this one. Determinant. So 11 times. 19 into 2. Come, 38.
19 now, okay.
19, 2. 9, 9, 18, 1. Yeah, 38. Minus 2, 36. Okay. So 11 times 36 here. Now here 5 into 2. How much? 10. Minus 10. Minus 2. Minus 10. Minus 2. Minus 10. Yeah. Minus 10. Minus 2. Yeah. Minus 12. Correct. So this here minus of minus it become plus. Now here 5 minus of minus plus. 5 minus of minus plus 5 plus 19. How much? Plus 5 plus 19, 24. Okay, so 24 times minus 6. Then you will get this much. 192 is the total determinant of this 3 by 3 matrix. Now determinant 1. How to determine 1? Just remove this column. 11 minus 5 minus 1. Remove this column and keep this 12 0 0. This is this one. Now find the determinant. 12, 19 minus 2 minus 1 and 2. First matrix. So next. Minus 5, 0 0 minus 2, 2 is the second matrix. And for minus 6, 0 19, 0 minus 1 is the third matrix. Now find the determinant 1, you will get 432. Now second one, 11, keep 11 minus 5 minus 1 as it is. This you have to remove. Minus 5, 19 minus 1 remove and keep 12 0 0. So keep 12 0 0. Now find the determinant 11 times first matrix 0 0 minus 2 minus 2. Next second matrix, that is 12 times minus 5 minus 1 minus 2 2. Third matrix minus 6 5 0 minus 5 0 minus 1 0. Now find the determinant, you will get 144. Third matrix. Third matrix is 11 minus 5 minus 1 minus 5 19 minus 1 12 0 0 is coming here. Now find the determinant 11 and this matrix is 19 0 0 0 minus 1 0. Now minus 5 matrix is minus 5 minus 1 0 0. Now 12 the matrix is minus 5 19 minus 1 minus 1. This is the matrix. Now what is the determinant? Find the determinant of this matrix and substitute here. You will get 288. So we got delta 1, delta 2 and delta 3. Now what is the I1? I1, current I1, loop current I1 is nothing but determinant 1 divided by total determinant. So you can find I1. I1 is nothing but determinant 1 by total determinant. So 432 by 192, 2.25 amperes. I2 determinant 2 by total determinant, 144 we got by 192, 0.75. I3 determinant 3 by determinant. So we got 288. So 288 by 192, 1.5 amperes. So these are the I1, I2, I3. But now we didn't finish it. But the question what it is I0. Question is what is I0, right? So what is I0 equation? I0 is nothing but I1 minus I2. So what is I1? 2.25 minus 0.75. How much? 1.5. So I0 is I1 minus I2. That is 2.25 minus 0.75, 1.5. This is your final answer. Okay. He didn't ask the branch currents. What is I1, I2, I3? No. What question? You can answer that one. No need to go further. You stop here. So this is this one. Now super mesh, I told you I will delete this topic. So no need to study this one in the mid or final exam. Now summary will once again we'll check. Node analysis is the application of Kirchhoff's current law, KCL, at the non-reference node, because we have two nodes there. One is reference node, which is also called ground node or zero node. Other than that, we call it non-reference node. We will write a Kirchhoff's current law to that non-reference node only. We need n-1 equations, not more than that. So we express the result in terms of node voltages. By using Ohm's law, we have to write the equation in terms of node voltages. Solving the simultaneous equation gives the node voltages. Second, a supernode consists of okay, this you can no need to study, the supernode not there. Okay, now mesh analysis is application of Kirchhoff's voltage law, like here current law, here voltage law around meshes. We express the result in terms of mesh currents. Here node voltages, here mesh currents. Solving the simultaneous equation gives the mesh currents. So here again this is super mesh, no need to study. Okay. Node analysis is normally used when circuit has fewer nodes equation. So there is a best practice. Sometimes I may give the circuit and you will not tell. I will tell use any method, mesh analysis or node analysis, get the result. So at that time what we have to do is node analysis is normally used when circuit has fewer nodes, means less number of nodes are there, then you can use the node analysis. Now when mesh analysis normally used when the circuit has fewer mesh equations, which is less, you can use that one. If you have two mesh equations and mesh loops and 4 nodes, which one is better? Mesh. If you have more nodes less nodes and more loops, then which one is better? Nodes. But here I will, in the exam directly I will give use mesh analysis, use node analysis. I will clearly tell. Yeah, I will tell you. I will in the question itself. I will tell use this analysis only. So don't worry about this one. This is for general knowledge. Okay, these are the 4 problems. I tell you 2 mesh analysis and 2 node analysis. You can solve at your home. Answers are there. Just verify it. If you are not getting, just WhatsApp me or tell me in the class. I will solve for you. Okay. So one is which one is this is the first figure. Check the figure number 3.52. This is the one for the first question. Next 3.51. This is the second. Next 3.54. This is the third one, not this one. And 3.60. This is the fourth one. So take the same circuit. So this is our